Before we begin example 14, we've got another typo here. So that denominator should be x squared minus 36. What we've got is, again, a problem where we can begin by factoring both the numerator and denominator. In this case, we can apply difference of cubes to factor the numerator, and difference of squares to factor the denominator. There are no factors that will cancel out, so when we look at finding our vertical asymptotes, we'll consider both x minus 6 and x plus 6 equal to 0, meaning we'll have vertical asymptotes at both 6 and negative 6. We can also then look at our horizontal or oblique asymptotes. By, in this case, considering our function to be approaching x cubed over x squared, which will reduce to x to the first power, meaning we have an oblique asymptote. In order to find that, we'll need to divide these two functions. Being sure to drop in placeholder terms where necessary. We'll start off by multiplying by x to get x cubed plus 0x squared minus 36x, and then subtract, which will leave us with 36x minus 125. So the result of our long division will be x plus 36x minus 125 over x squared minus 36. But we're considering x approaching positive and negative infinity, extreme values. So since we have a larger denominator, or a larger exponent in the denominator here, this whole expression is just going to go to 0, meaning our result is just x. So we have an oblique asymptote defined by y equals x. So the other simpler way to say that is, we're not concerned with what our remainder would be, just the x term and any constant term. So we have our two vertical asymptotes. We have our oblique asymptote. From there, what we can do is look at identifying some test points or some fill-in points. Which again are just arbitrarily chosen to give us an idea of function values that we're hitting to start narrowing our approach here. We could evaluate h of 0, which would come out to be approximately 3.5. We could evaluate h of negative 5 and h of positive 5, which are both very close to our asymptotes. This would give us approximately 22.7 and 0. So at negative 5, we're approaching a larger function value. At positive 5, we're hitting 0. If we wanted to start to see what happens even as we get a little bit closer to that asymptote, we could evaluate h of 5.9, which would be approximately negative 67.5. So as we get closer and closer, we're going to be heading down into the negatives. So we end up with a middle section that follows this pattern. Not drawn incredibly well there. but curving down, and then as we approach that asymptote from the left, is decreasing. We know the multiplicities of our vertical asymptotes are odd, which means our function has to be approaching those asymptotes in the opposite direction as we approach from the other side. And then they're also bound by that oblique asymptote, so somewhere these functions are going to curve and start following the oblique asymptotes, or follow the oblique asymptote. We only have one. So what we end up with is a curve that, roughly sketched out, would look something like this. One important thing to note is that we do have a point where our function crosses over that oblique asymptote. That's okay. We can never cross over vertical asymptotes, but the horizontal and oblique asymptotes we may cross over, they really just dictate our behavior at the extreme, so at the far right and far left of our graph. In between, we may cross over once, twice, maybe more.